Newton's laws of motion. The first law of motion states that an object at rest stays at rest and an object in motion stays in motion with the same velocity and in the same direction unless acted upon by an unbalanced external force. With this law we can say that the object will travel a straight path if it is initially moving unless acted upon by an external unbalanced force. Newton's second law of motion states that the acceleration of an object is directly proportional to the force applied to it and inversely proportional to its mass. The original statement of this law is based on the concept of momentum. It states that the rate of change of momentum of an object is directly proportional to the force applied, and this change takes place in the direction in which the force is applied. This is a relationship between mass of the object, the amount of force that will make the object move, and the rate of change in its movement or the acceleration. This means that an object will accelerate, change its velocity, or change its direction of motion if it overcomes equilibrium conditions. Meaning there is a net force. Here are the equilibrium conditions. Here are the non-equilibrium conditions. Take note that the positive or negative sign may indicate the direction of the net force present, or acting along their respective axes. The mathematical form of Newton's second law, relating the force, mass of the object, and acceleration is given by where F net is the net force, m is the mass, and a is the acceleration. We have for the x, y, z axis unit of force. The unit of force must be kilogram times meter per second squared, which is called as Newton. So 1 Newton is the amount of force needed to accelerate 1 kilogram of mass by 1 meter per second squared. This is done to honor Sir Isaac Newton, who lived from 1642 to 1727, a great physicist. Two other units of force which we encounter sometimes are the dyne and the pound. We go to Newton's third law of motion. This states that for every action, there is an equal and opposite reaction. In simpler terms, this law states that when one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first object. The forces are always of the same type and occur simultaneously. These forces are referred to as action and reaction forces. Mathematically, if object A exerts a force F on object B, then object B exerts a force negative F on object A. The magnitudes of the forces are equal, but they act in opposite directions. To sum up,